please pause the video and reread the question if you haven't done so already. Before we can find the volume of this solid, we're going to have to graph the two given equations. You may find it helpful when graphing the first equation to isolate y. When doing so, you're going to have to square root x minus 1. We must remember that that includes both a plus or a minus. So you may also then plug in this equation as well as the second equation into a graphing calculator to get a look at what the graph looks like. Here is the graph of the two equations. It's a little bit crude, but it'll serve for our purposes. We are revolving around the y-axis, so we're going to have to go ahead and draw a second region that's essentially a reflection across the y-axis, which should look something like this. Again, a little bit crude, but it will suffice in showing us that there's going to be a sort of depression or cavity in the middle of our solid when we revolve it around the y-axis. And whenever you have that situation, a cavity, depression, a hole, if you like, then you're going to have to use volume by washers typically. So let's look at that formula. Note that this formula in this case is in terms of dy because we are revolving around the y-axis. We will also note we have lower and upper limits of integration, which we will see later are y values. Now let's try to figure out an expression for both little r and big R. To do that, you always want to measure from the axis of revolution, which in this case is the y-axis, until you hit your first curve. That would be our little r. And then for your big R, you are once again going to measure from your axis of revolution until you hit the second curve, which is right there. A little bit crude, but hopefully that picture suffices. Now because it's dy, we want both big R and little r to be in terms of y. We can see, if we look carefully, that little r strikes the sideways parabola, if you will, and we know that the sideways parabola takes the form of y plus 1 plus y squared. So little r is going to be 1 plus y squared. And then big R, if we look carefully, kind of stretches out and strikes the straight line. Now that's in terms of x minus 3, so we would actually have to add 3 to both sides of this equation and determine that the big R is going to be y plus 3. So what we'll do is we'll plug those in, we'll square them, we'll collect like terms. What remain to be determined are the lower and upper limits of integration, the so-called C and D. And in order to determine those, we can simply set the two equations equal to each other. So perhaps we'll do that over on the side here. Now that's a quadratic equation. We'll have to gather all the terms to one side so it equals 0. We'll factor and then solve for each value of y. Thus our lower limit C is -1 and our upper limit D is +2. So we'll plug those in for the lower and upper limits. Now this is a relatively straightforward integral, and so I'll go ahead and compute that. And then the last step is to plug in the upper limit, then the lower limit, subtract those two results, and then multiply by pi. And when that is accomplished, you should obtain 117 pi over 5.